Hello and welcome back to our science interactive notebook. Today we are going to be exploring sound waves. So these are all the things you're going to need. You're going to need your science interactive notebooks. You're going to need this page right here that says sound waves. Okay, if you don't know where that is, look in your packet. It's under this page right here that says sound waves. We don't need this one though. We'll just need this one today. We need this, sound waves. We need our interactive notebook for science. We need our pen or pencil or something you can write with, some colors to brighten it up, some scissors of course, and of course glue. Okay, so if you don't have all of these things ready to go, make sure you pause the video and go grab them, and I'll wait here. Alright, so everyone should be back now. With all the materials. Alright, so we are looking at sound waves, which is on this paper. We have 2 copies. Just in case you make a mistake, we're only going to need one of them, though, today. So that's where we'll start. We'll start by cutting out our sound wave paper. Alright, so here what we have is an example of 4 different types of sound waves. Each sound wave represents a different broad type of sound that you might be familiar with. We're going to use these examples to learn a couple terminologies, a couple new words that have to do with in science that have to do with waves, specifically with sound waves today. So you notice I'm just cutting out this whole rectangle first. I'll be making more cuts, but for now, just the rectangle. There we go. All right. There we have it. All right, so I have this right now. And what I'm going to do is open up my notebook to the next page. Next blank page. Remember last time we looked at, we looked at circuits. We did 2 pages, one for series circuits and one for parallel. Today we're just going to do one, so I'm going to flip to the back of that. And actually, remember we had an empty page. I could use that if I want to. I might save that though. I'll flip it to the back here. Alright, oh, I forgot to mark. This was page 17. Just marking all the pages so I keep them in order. That was page 17. This was page 18. This is page 19. So we are on page 20 today. Wow, look at that. Page 20. And I will be gluing in my little sound wave chart here. At the top, let me write the title here. It's going to be Sound Waves. Alright, so when we have been looking at waves a little bit. And remember, waves, just like the name of the ocean waves, behave much the same way. Right, they go up and down and they go out. Okay, so they have direction, 2 types of directions. Okay, shown here. They have an up and down direction and they have an outward direction. Remember, we could think of it even like our maps to bring in our geography. What we've been learning in geography, they have lines of longitude and latitude, right? So waves travel in a direction that goes forward or backward, depending on where you are in relation to them. But usually the waves go outward, and as they go outward, they go up and down, up and down. And there's some key terminology that we talk about when we talk about waves and how they work, right? This is the distance, okay, that it travels. Okay, so either over time or over space, this is distance. can go ahead and put that in there. Distance. It goes. Now when I talk about how high up and down it goes, that's going to be what we call amplitude. Okay? Amplitude. I'm going to zoom in for you guys there. This is just the first one you can see, but it applies to all of those. We are talking about sound waves today, but this also applies to light waves. It also applies to those ocean waves. Any type of wave, we use the same terminology, the same words in science. And actually, everything in science can kind of be boiled down to waves, right? Everything we see, everything we hear, everything we can kind of sense can be thought of as a wave. That's one of the interesting things of science. But waves go across a distance over time and over space, and then how high they go up and down is their amplitude, right? So their amplitude over this is their, like an average sound. But you can see waves go up and down over this imaginary line. They don't just go up and stop and then go back up. They have a crest and a trough. Crest and a trough, up and down. And you can see that different waves have different amplitudes, right, over the distance or time that they go. I'm going to look at that more. Now, between two crests is what we call wavelength. I'm going to mark that here. That's called a wavelength. Okay. Now it's the same here. This to this is a wavelength. Now notice the wavelength from this wave, the top, where we say the crest, from the top of one crest to the top of the next crest is the wavelength. And notice the distance is going to be different for different types of sounds. Okay, that's what we're going to be learning. But these are the three terminologies that we're going to learn today. Distance is how far the wave will travel. Amplitude is how high the crests go of the sound. And wavelength is how close together the crests are. Okay. So now what we're going to do is we're actually going to glue in this piece. So let me zoom out for that. I'm going to fold along that black line. When I do that, after I fold it, right, like we have been, I'm just going to glue this edge. Okay, because again, I want my thing to be able to open. And I'm going to line that up with the red line. There we go. So the whole thing will open and close, but make sure it sticks down. Before I start writing, I'm going to cut my flaps. So this is where I'm going to cut along these black lines. And if you're like me and your glue is just not the best, you might have to re-glue this. Yep, mine came off already. I think I might need to start using a different glue. That's okay though. Put bit more glue on this. But notice I don't want those flaps to be cut all the way. I want to let them still be connected to where I glued. And I want them to be able to open up and down. Perfect. Alright. So now, my colors, I'm just going to use to differentiate the waves. You can pick whatever color you want. I'm going to do a nice blue, just to sketch over this wave. One thing this will do, I know it might seem silly, but I'm going to sketch over this just so I get a feeling of how a wave moves, right? It goes up and down. And that way, when I think about these type of waves, I'll have this type of feeling, okay? And this type of wave is going to be a low pitch. I'll turn it to write it this way. This is a low pitch. P-I-T-C-H. Okay? So after I write low pitch, let me trace over it again so I get a good feeling for what a low pitch wave kind of feels like. Okay? Now how would I describe a low pitch? I'm going to write that under here. A low pitch wave. A low pitch wave. Alright. And then I'm going to describe it here. But let's take a look. How would I describe it? How would you describe it? Okay, comparing it to some of the other wavelengths. Or I'm sorry, some of the other waves here. Right? The distances of all the waves are kind of similar. We're not going to worry about that. But let's look at the amplitude and look at the wavelength. So a low pitch, specifically with the wavelength, it has a long wavelength. So low pitch sounds have longer wavelengths. Okay, this is going to be a high pitch that we're going to look at next. And it has short wavelengths, but these low pitch wavelengths have long, or those low pitch waves have long wavelengths. So a low pitch wave sound has long wave lengths. Okay. Period. That's how I would describe a low pitch. They have long wavelengths. And again, the wavelength is the length from one crest to the top of the next crest. In contrast to that, high pitch I'm going to color red. Again, I just want to trace it to get a good feeling of high pitch. So when I think of high pitch, I'll have a muscle memory. Right? So that high pitch, notice the wavelengths. The waves are much closer together for high pitch sounds. So a high pitch sound has short wavelengths. So a low pitch has longer wavelengths and a high pitch has short wavelengths. That's the difference between these two types of sounds. Now you may be saying, what does it mean by low pitch and high pitch? Okay, low pitch is when it's a very deep, low sound. Okay, those travel slower with this higher amplitude and the longer wavelengths. High pitch is when it's really high. Let's think of helium, right? Sounds funny. So it sounds sped up, sounds really fast, and it has this much higher pitch, right? Those high pitches, notice the amplitude's the same, right? That's the same between the two. Amplitude has to do with how loud it is. So even at the same scale of loudness, two sounds could be the same, just as loud as each other, but one will be low pitch if it has this like very long wavelength, and one will be high pitch if it has a very short wavelength. All right, I know that's kind of silly, but hopefully that helps you remember it. All right, so now let's talk about amplitude. Okay, again, amplitude has to do with the height. So if it has a high amplitude, right? Amplitude, the height of the wave, again, has to do with the loudness. So this would be a very loud sound. Loud sounds have very high amplitudes. So I'm going to give that a color. Give it green. Again, trace it so your hand gets a nice, or your brain too gets a nice muscle memory of high amplitude, loud sounds. And I want to say that a loud sound has a loud sound wave has, or a loud sound has a wave with high amplitude. A loud sound has a wave with a high amplitude. Okay. A loud sound has a wave with a high amplitude. You can pause or rewind if you need to. And this would be, of course, a very low amplitude. Now notice the wavelengths are pretty similar, right? This has a little bit higher wavelength, so it's a little bit higher pitched. But the loudness doesn't affect the pitch necessarily, right? So you can have the same pitch for a sound, but one could be very loud because it has high amplitude, and one could be very soft but at the same pitch. So what's a color I haven't used yet? How about orange? Notice this would be a soft sound, right? Like a whisper. ASMR kind of sound. Get a nice feel for that as I trace it. The wave, it's very low amplitude. The lower it is, the harder it is to hear it because it's so low. Alright, so a soft sound has a wave with a low amplitude. And notice we use low in two different ways here. Low pitch talks about how low the sound is, right? So how deep it is. This low means how shallow the height is. Okay. Alright, so there we go. We have low pitch and high pitch. Low pitch, pitch is how far away the wavelengths are. So a low pitch has wavelengths far away. High pitch has wavelengths that are very short, near each other. But a low sound has to do with the amplitude, or sorry, loudness. Loudness has to do with the amplitude. So a loud sound would have very high waves, and a soft sound would have very short waves. Alright, so make sure you have all that, and you have all the notes we just wrote in your book, over on page 20 if you were following along. Okay? And you can always pause and rewind, but we're going to keep this in our notes, so every time we study sound, or look at sound, or even waves, we could refer back to this for a quick refresher. Alright, well thank you for joining me, and I'll see you next time. Take care.